There are many ways to set this problem up in Excel. I'm showing you a possible way, and you could do it differently. In general, it's a good idea to separate the parameters from outputs and calculations. So if the parameters are the input things, sort of the data that we will possibly want to change, if we want to look at how things change, if we have more resources, if a procedure takes less time or more time, reimbursement is different. So some of the parameters that we have here is the percentage of patients for whom the treatment is appropriate. So that's 20%. So I have it here. I put the number into cell C3. And I'm using, if you look at the name box, it doesn't show C3. It shows a name, percent treatment appropriate. One of the things that sometimes is useful in Excel is to name cells. When you name a cell, and if you drag a formula or copy a formula, the cell that is named is treated as an absolute address. Why would you use name cells? Sometimes it makes it more clear what you're doing. If somebody else is looking at your spreadsheet, at the formula, it can be more clear if you're using good names for the cells to understand what you're doing. I will skip for now how do I name cells, but just wanted to bring your attention to that it is possible to name the cells. So we have this percent of patients whom treatment is appropriate, percent who need correction, payment for the initial treatment, and I have here information on resource availability. So I have a resource, how many hours of that resource I have per week available. So I decided that I will analyze this problem based on the week, and the quantity. So I have a single doctor, and if I had 2 doctors, then I would put 2 here. Now, what differentiates resources from each other is where they're needed in the process. So one type of resource would be different from another type of resource based on the units of the resource that are needed for each step. Here we have 3 steps: the screening interview, the initial treatment, the correction treatment, and I have here 1, 1, 1. So I'm only dealing with a single resource, and I need 1 unit of resource for each one of these steps. I also have the information here on duration. So the first step takes 60 minutes, the screening interview. The initial treatment is 180 minutes, and the correction treatment is 30 minutes. There's a few things from the point of Excel to look at here. So the 60 minutes, there is a comment here. In this column, units of the number are part of the cell number format, so the value in the cell is numeric. So you can see in the cell it's written 60 minutes, but if you look here in the formula bar, the number is 60. So let me just show you here. If I type in 60 minutes here, you can see the value in the formula bar has minutes after it. And for example, I cannot take this and multiply it by 2. It's not numeric. On the other hand, I can take the value in this cell and multiply it by 2, and I get 120. So the way to do that, if you want to add units, you can select a cell. You could select the format, custom format, and for example, I have a format here, and I can add to it hours. So now in this cell F13, I have 1 hour, and I can copy this format, let's say down. Okay, so the values, I can still manipulate it. The values are numeric, and I can manipulate them even though they have the units after them. So that was just an aside. You could also add comments to the cells. So we have a comment here, and the comments can be, so to show you how to add comments, I insert a comment, units of hours here, and I can either choose to show the comment or hide the comment. So if I show the comment is available at all times. If I hide the comment, It's only available when when I hover over the cell. And I can delete the comments, of course. Delete this comment here as well. So to go back to where we were, so I have the first step. It takes 60 minutes, 180 minutes, 300 minutes, and here I translated these minutes into hours. Duration is in hours. Another thing that I did is that for each step I added a revenue, so the screening interview doesn't get anything. Initial treatment, it is a link to this cell, and you can see I'm using a name. Payment for initial treatment is pointing to this cell, so this cell has the name. And correction treatment, there is no revenue. Finally, I just made up some number. 100 is a good number to start with. I don't know the capacity, but I'm going to start out assuming 100 patients arrive. What percent of them will get initial treatment? It's patients who arrived for the initial consult times the percent of the ones that had the treatment for whom the treatment was appropriate. And then correction treatment was the patients who received initial treatment times percent who needed correction. So now I have all this data set up. Again, I have some input parameters. I'm describing a resource by the hours that the resource is available and the quantity of resources that are available, but most importantly, by the units of resource that are needed for each step. Each step has a duration. It has revenue, and if I start out with, say, 100 patients arriving for the initial step, I calculate here how many will go through the next steps. So now this is my input data, and with that I can start the analysis. So here we will analyze the capacity. So the first thing that I did is figure out for the 100 patients that start out, what is the total time that had to be spent. So here I use the sum product, and what am I multiplying? So I have 100 people, I need 1 hour per person and 1 unit resource of the for this task. So the number of hours that I spend here of my resource is 100 times 1 hour times 1. The next is the initial treatment, and I have, out of 100 people, then I have 20 going through this, so I'm multiplying 20 by 3 hours by 1 unit of resource per step. So that's 20 times 3 times 1. So I got 100 here, plus 60 here, plus the correction treatment. That's if we started with 100 people, 20 will get the initial treatment. Of them, 10% or 2 will get the correction. So it's 2 times 5 times 1, so that's 10 more. So the total time spent by my resource on these 100 patients that are arriving to a clinic will be 170. You can see that. So what is the average time spent per person? So I calculated in G19 I had 170, and I'm dividing it by the total number of people that are getting initial consult by the 100, so it's 1.7 hours on average per person. So if we, again, this is weighted averages, so every person does not get 1.7 hours. Some people are only coming in for the initial treatment, and they are getting 100, they're getting 1 hour each. Then there are 18 people that are getting the initial treatment and the screening interview. So for 18 people, we will get 1 hour from the screening interview plus 3 hours from the initial treatment. So these people will get 4 hours. And then there will be 2 people out of 100 who will get the screening interview, the initial treatment, and the correction treatment. So they will get a total of 9 hours spent on them. So if we just do that again, so 80 people, there'll be 1 hour spent on them, and 18 people, there'll be 4 hours spent on them, and 2 people, there will be 9 hours spent on them, So if we do the sum product of that, and we divide it by 100, that will be 1.7 also. So there's several ways to do this calculation, but here I added everything up and then divided by 100 also got 1.7 hours. Okay. So now my total resource pool availability, I have 40 hours per week per resource, and I have one resource, so that's I have 40 hours available. And so what is my weekly capacity in terms of patients that are arriving sort of the for initial step of these average patients? It is 40 hours divided by 1.7 hours. So on average for every patient that arrives, I spend 1.7 hours. But there is no single patient on whom I will spend 1.7 hours. On 80 patients, I'll spend an hour. On 18 patients, I'll spend 4 hours. And on 2 out of the arriving patients, I'll spend 9 hours. Okay, so back to that. So how many patients can I handle per week arriving is 40 hours divided by 1.7 hours per patient, so I'm getting 23.53. Okay, so if I have 100 patients, what is going to be my revenue? Here I'm doing sum product again. So for these 100 patients that are arriving, I'm not getting anything for the initial screening interview. I'm getting $1,000 from the 20 patients who will get initial treatment, and I'm not getting anything for the 2 patients on whom I'll perform correction. So the sum product will be $20,000. And now, so what is my average weekly revenue? So instead of 100 patients, I will be able to handle per week 23.53 arriving patients on average. So the share of this 20,000 that I will be able to earn is 23.53%. And I can calculate it as I'm taking this G25 total revenue, multiplying it by 23.53 and dividing it by 100. So on an average week, if I'm working 40 hours per week, and I'm as Dr. Solo, my revenue is $4,705.88, assuming I'm working at full capacity, and my full capacity is 23.53. So here we'll, in this analysis, we'll do a modification, and now we will have an assistant to our Dr. Solo who does the procedures, and the assistant will do the screening interviews. So Dr. Solo will not do any more screening interviews, but we will hire an assistant. The assistant will work 40 hours per week and will do the screening interviews. So I've recorded an assistant here, and the assistant, we can see I need 1 unit of Dr. Solo's time for the initial treatment, for the correction treatment, and the assistant, 1 assistant for the screening interview per patient. So now, so the data is entered here. So now we can see that our resources are different because they have this mapping is different between the tasks and the number of resources that are needed for each task. And we have 40 hours available of assistant, and we have for now 1 assistant. So how do we do the analysis? Let me move this away. Similar to the way we did the analysis for the, whoops, I wanted to move that away, sorry. Similar to the way we did the analysis before, for Dr. Solo, I'm calculating using sum product the total amount of time that Dr. Solo will spend on 100 patients. And now I will do the same thing, use sum product to calculate the amount of time that the assistant will spend. So, so the assistant will spend 100 hours for 100 patients because the assistant will only do the screening interviews, and Dr. Solo will spend 70 hours. It will spend 3 hours on the 20 patients out of 100 that will need initial treatment, and 5 more hours on each of the 2 patients that will need correction. So average time is, again, actually, I didn't mean to do this. Average time will be the time in, that's now in G19, divided by the number of patients that arrive, and the same formula here, the value in H19 divided by the number of patients arriving for initial consult. The total time that I have available for the Dr. Solo is 40 hours per week times 1 of Dr. Solo's, and the same for the assistant, 40 hours per week times 1 assistant. And then, so what is my weekly capacity in patients arriving for the initial step? For Dr. Solo, it's 40 hours divided by 0.7 hours, and for the assistants, it's 40 hours divided by 1 hour. So what is the system capacity? It's the capacity of this resource that has the least capacity. So I'm using a minimum function to find the minimum of these two, and the minimum is going to be 40. And then where's the bottleneck? Here, I'm using a combination of index and match. So match will find me the column in here, in G23, that in H23, that matches this value, 40. So that's going to be column 2. And then I'm looking up in this array, what is the value in the second column, and that's going to be assistant right now. Okay. And now what is my total revenue per 100 patients? I'm doing some product again. So nothing from the initial interview, $1,000 from the 20 patients that go through the initial treatment, and nothing from the patients who need correction. And then what is my average weekly revenue if I do it at full capacity? So it's my full capacity per week divided by 100 patients times 20,000. So that gives me $8,000. Now what will happen, let's say if I want to do some analysis, let's say I have 2 assistants. So now I have, you can see what changed here. It's 80 hours here. So my 2 assistants can handle 80 patients. And now Dr. Solo becomes the bottleneck. Weekly capacity is determined by Dr. Solo, and the average weekly revenue changes like that.